Okay, there you go. This will probably be a disaster, but that's okay. Disasters are the most fun if things go properly. That is boring as hell. Again, hey, how did you make all your money? Well, it was really boring. I did a whole bunch of work. People pay me for the work. I put it in the bank. I got wealthy. That is boring. How did your life go to absolute hell? Well, I zigged when I should have zagged, moved to a different place, fell in love with the wrong girl. That turns into a whole wonderful story. So anyways, everybody remember, failure is the most fun. It does give you the best stories at the end of the day. So how many people here have the most obnoxious thing you're going to hear today? How many people here kind of like sort of know who I am, just out of curiosity? Wow, that few. Okay, that's cool. So if you don't know, I'm known as Eli, the computer guy. I've been doing technology since 1996. Shipped off to basic training back in March of 1996. Did electronic repair in the Army. Got my MCSE and NT 4.0 back in 2000. Worked in the corporate world back when I was a 24-year-old, being flown everywhere because I was stupid enough to take the job. Went through the dot-com bust, became a consultant, had a company with 9 employees. Basically started doing education on YouTube back in 2009 because I was literally sitting in a master's degree program. I had just had 9 full-time employees before everything blew up because of the Great Recession. I was looking at the material that our instructor was teaching us and realized I would not have paid my own employees 25 more cents an hour to know the crap that I was learning in a master's degree program. So I had this idea. I was like, what if, and again, this is 2009, what if, there was on-demand, like video training? Like, what if you could go to your computer and just learn about the things that we get paid for? And so I actually built my own infrastructure back in 2009, put it into a co-location facility, and created long-form video classes, everything from the OSI model to Linux, all kinds of different things. So things change. Again, sometimes people get surprised about this, but 16, 17 years have actually gone by, so the stuff that was successful 15 years ago might not be the best way of doing things today. And so one of my questions now is, I brought the real world onto online education back in 2009. That's, again, finding online education back then was pretty difficult. My question now is, can we take the lessons that we've learned from online education and bring that into the real world? Any old time there. So we do Silicon Dojo. Basically, Silicon Dojo is authoritative, gatekeeperless, free to end user, hands-on technology education that empowers you to do whatever the hell it is that you want to do. Basically, it is education. You RSVP, you show up, you learn, you go away. Isn't that kind of wonderful? We are crowdfunded. We are in the black by a hair's breadth because of my viewers and people that support the project. And again, it's also that kind of idea of if you have the money, if you think what I do is valuable, throw money into the account. If you don't. Let's see how far we can get. And the great part about this is I don't have sponsors. I don't have to kowtow to, jobs programs or any of that kind of stuff. We can just do education. So anyways, this is what we do. If you go to silicondojo.com, you can see the list of classes that are currently up. We do the classes in Durham. There's going to be one on Wednesday. We do classes in Asheville. And there's a whole bunch of stuff going on. So that's basically what silicondojo.com is, and that is more or less what I do. And so what we're going to be doing today, is letting AI out of the box, right? One of the big problems that I see right now in this whole world of artificial intelligence is people think this garbage is magic, right? When the normies think that AI is magic, that is dumb, but that is the right of a normie. They decided to be normies. They decided to not understand what TCP/IP is and OSI models are and replication and all that kind of stuff is. If they want to think artificial intelligence is magic, fine, right? They think everything is magic. They think their Outlook hates them. It's like, no, I hate you. Outlook doesn't, right? The problem that we're running into right now, though, is that this idiocy has infected technology professionals. Right? When we talk about artificial intelligence, one of the big problems that we run into is the story behind words. If you ever read Plato talking about Socrates, right? Again, it's kind of like the Socratic method. When you say a word, what does that word actually mean? It carries a whole story behind it that goes far beyond that word. Ugh. The problem that we get into now, right, is we talk about artificial intelligence. Right now we are at an AI conference that I'm probably going to get kicked out of and never be able to come back to again because I'm talking about this kind of stuff. But we talk about artificial intelligence. Think about the story in your mind about what that means. Right? We talk about AI. You think about Terminator. You think about Jetsons. You think about HAL. You think about 1,000 garbage sci-fi movies that you've heard that tell you what artificial intelligence is. So when you're told we have artificial intelligence, we're at the cusp of artificial intelligence, right? You have this whole story that goes along with it. Here's what I want you to think about. What is your story for LLM? What is your story for RAG? What is your story of Mamba 2 versus Transformer architecture? What is your story about neural networks? What is your story about the technologies that build this thing called artificial intelligence? And what you realize for most people, if they do have a story, it's probably screaming about how the crap breaks 90% of the time and doesn't do what the hell it's supposed to do. But beyond that, right, you don't. If I told you that I was going to spend $1 trillion investing into LLMs, would you buy that? If somebody told you LLMs are going to solve physics, again, this is actually something that I heard out of one of these people. It's going to solve physics. Again, would you agree with that? Again, but when we say artificial intelligence, when you hear that AI is going to cure disease, somehow that's sensical. But saying that a model is going to cure disease is absurd. So anyways, one of the things I want you to be thinking about when we start talking about this artificial intelligence and about this technology is thinking about the technology itself, thinking about the products and things that go into building solutions, and then think about how you're actually going to build and deploy these things, actually make this stuff valuable, right? When we used to deploy email servers, once you got done spending all the money, the CEO expected email to be sent, right? If I built an email server and at the end of the day, no emails got sent, my day was going to be very, very bad, right? But for some reason, again, with this whole artificial intelligence thing, we want you to use AI. So anyways, this is one of the things I talk about. AI, as I argue, AI is just a stack. If you look at artificial intelligence and you look at the stack, it looks like every other stack that we've ever used. We have UI and UX of some degree, right? That's going to be an input, outputs. That is going to be going to a back-end programming language. Most likely it's going to be Python. There's going to be something like Node.js. It's going to be on some kind of operating system or a platform as a service, something along those lines, like Linux or whatever else. You're going to have data stores. You're going to have record stores of some type. You're going to have API calls, whether that's an Active Directory API call or a REST API call to something else. And then somewhere in there, there's going to be like this little teeny layer, and that's going to be your model, right? And maybe that model is actually going to be a stack. It's kind of interesting. You look at IBM, they're building entire like LLM stacks, which is kind of interesting. But even when you have that whole LLM stack, that's within all of this other stuff. And so that's one of the things I want you to be thinking about whenever you're dealing with these artificial intelligence tools. And you think about deploying this into the real world, one of the big questions is what are you actually trying to accomplish? What are you actually trying to build? Is this the route that you want to go down? So anyways, today, something kind of interesting for folks to see. We're actually going to be using a Raspberry Pi. So we're going to be using a Raspberry Pi 5. I'm going to show you some of the stuff with this whole concept of artificial intelligence and building up a system. And then past that, one of the things we're going to do is we're actually going to be using an Arduino to create a larger system. So basically a telephone-operated system where imagine you have an HVAC system, like an environmental control. Basically, you can have an Arduino with Wi-Fi that is able to communicate up to a server. You can use Twilio and 11 Labs to be able to communicate with that server. And then you can actually just have a nice little conversation about what's going on with your environment. Hey, what's the temperature? Again, if you have more sensors, what's the humidity? Is there water in my environment? Is there all that kind of stuff? And then you can trigger events to happen. Again, turn a light on or turn a fan on or that type of stuff. So that's what we're going to try to show you folks today. We will see how well that works. So anyways, okay, let's start this off. Okay. Let's go take a look at some code. Yay, code. Yep. Is this screen okay? Yay or nay? Nay? Okay. Well, I'm going to turn some lights on. It's okay. If he falls asleep, it's all your fault. Let's see here. Boop. Is that better? Boop. Oh, God. If I fall asleep, it's your fault. Okay. Lordy. This is why you buy projectors with lumens. I just bought this projector, 5,500 lumens. It's nice and bright. That one's a little bit darker. Anyways, okay. Oh, I'm gonna go take a nap now. So if you look at your books, let me grab my book. If you look at your book, so in your books there is code. Because again, I have been sitting in your seats and there is nothing more obnoxious than a programmer flipping through their VS Code at 1,000 miles an hour trying to explain to you everything going on. And you're like, I can't tell what you're doing. So anyways, we have this nice little piece of paper here to kind of show us what is happening. And you can take a look. And again, you can scribble on this stuff as you see fit. And I just never have enough tables. All right, let me put this here. Okay, so first project we're going to be dealing with is going to be a little Raspberry Pi thing. So we're going to be dealing with a Raspberry Pi. Oh, come on, little guy. Come on. So we got a Raspberry Pi up here. I swear. I swear. So we had a whole problem with the Raspberry Pi. So anyways, come on. Lordy. Okay, that's going to be one of those days. If we take a look at page 2, basically when we start talking about a Raspberry Pi, yeah, again, whoo, can you all see that? Probably not. Anyways, what a Raspberry Pi is, so everybody understands this, is a Raspberry Pi is a full-fledged computer. Right, so basically this is a computer that can run Ubuntu, it can run Linux operating systems, can run Nginx, it can actually even run models on it. So it can run the Granite 4 models, it can run 350 million parameter model, 1 billion parameter model, even a 3 billion parameter model on these little guys. And these are full-fledged little computers here. Why these are valuable versus buying something like a mini PC is it gives you access to what are called GPIO pins. So basically what these GPIO pins allow you to do is it allows you to control things like LEDs, allows you to control anything that you can trigger. So we're going to have a relay. We are going to have a relay that is going to turn our thing on and off. There we go. And a whole bunch of other stuff. So basically this is what we're going to be talking about when we talk about our Raspberry Pi. So when you're going to go to set up a Raspberry Pi, just so you know if you're ever doing this for yourself, one of the big things you're going to need to do a virtual environment for Python. It is actually going to require you to do a virtual environment. When you do speech to text, this gets a bit bizarre. This is one of the problems we get to, and again, the real world trying to deploy stuff, is operating systems change and they don't document things great sometimes. So one of the things here I show you on page 2 is if you want to do the speech to text, what we're going to be doing. Speech, so I talk to text. You use something called the speech recognition model. You then have to install something called Pi Audio. Again, that's fun. Anybody here had the misery of dealing with Pi Audio before? Basically what Pi Audio does is it allows you to interact, basically connect your microphone to your Python script so you can do things like speech recognition. The problem is it is a bit of a disaster. Anyways, you're going to have to install a Pi Audio if you want to deal with it. We are going to be showing you today how to use the OpenAI Whisper model so you can actually use a speech-to-text model directly on this little Raspberry Pi, if you have a Raspberry Pi 5. We're also going to be dealing with Google. So Google allows you to connect to their API services. Basically, they have some kind of weird developer account. Again, don't put this into production unless you're okay with things going to crap every once in a while. So basically, with the Google's speech services, they have provided an API key that kind of sort of works unlimited. So again, for testing demonstration environments, it works very well. If you're actually going to deploy this into the world, you do want to get your normal API key for that. Beyond that, we're going to have Ollama. So we're going to install Ollama on here. If you have not dealt with Ollama, Ollama is great. Let me see this. So Ollama, basically what Ollama is a model framework that allows you to very easily use these models directly on your computer. So whether you have Linux, whether you have Windows, whether you have Mac, you can install this very easily. And then they have a whole bunch of models that you have access to. At this point, they have models, again, for Vision, so not only do you have like the normal LLM models, but you can do vision, so it can see what's in an image. You can actually create images now, at least with the Mac operating system, so if you don't want to pay for DALL-E, you can do that type of thing. But basically that is what Ollama is, and that is the framework that we're going to be using today for these little projects. We're also going to be using OpenAI. So OpenAI API, if you have not dealt with this, is great. Log in. So basically the great thing with the OpenAI API, so most people when you hear about OpenAI, they know about ChatGPT. And so ChatGPT is a finished product. You go to chatgpt.com, you use it however you want. Basically with OpenAI API, what this is this is an API interface. So basically with your Python code, you can directly connect to their infrastructure to be able to do things such as be able to get answers from their models. You're able to create images and do all of that kind of thing. The cost for their usage nowadays is incredibly cheap. It's down to about $1.50 per something like million tokens. So it is a great way of being able to provide LLM or model services on your low-powered computer. Because that's one of the things to be thinking about with architecture, right? So this is something, this is something called a Raspberry Pi Zero W version 2, right? This basically has no power. If we call this a potato, this would be a tater tot, essentially, right? That's how low power it is. But the thing is, one of the things I want you to be considering when we start talking about architecture is you need to be thinking about where are the resources being consumed, right? So we talk about running these models, right? And this thing right here, it's brand new. I just got it like 3 days ago. It's a stupidly expensive M5 MacBook Pro. So everybody's like, if I'm going to do AI, I need that thing. And you probably don't. The only reason, I want everybody to understand, the only reason I own this thing and I wasted the money on this thing is I do education, right? So anybody who's been in my classes knows I run these models and then I do the Eli dance for a little bit until the model responds. Because again, when you're using a slower computer, it takes a while. So again, teaching classes, that's why I got this thing, so that we have better local performance when I'm trying to show people what the hell's going on. One of the things to consider, though, is depending on your particular situation, do you actually need stuff to be running local? Right? Do you need it here, or can those AI services be run up on somebody else's servers? Right, so again, think about this. With OpenAI, you pay $1.50 per million tokens, right? 1,000 tokens equals about 700 words. A million tokens equals about 700,000 words. 700,000 words apparently comes out to something like the Lord of the Rings trilogy. Right? That's literally how much information you can push and pull to OpenAI for $1.50. So one of the things to be thinking about when you're designing your little projects is this could be your quote-unquote AI server. Why do you need to buy a $40,000 NVIDIA GPU when Sam Altman is more than happy to burn his $40,000 GPUs in order to provide you services? And so that's one of the cool things with these API services is literally I can, with a little, again, Python code is going to go at warp speed on this little guy. But so this guy can interact with the API and you get all the power of OpenAI from something like this. So anyways, that's one of the valuable things with OpenAI. Then the final thing is text to speech. So we have speech to text, and then we're going to get text to speech. With this, we're going to use a simple module called PyTTSX3 that uses something actually built into Linux now called eSpeak. And basically, it's a speech simulator that's already built into your system. So again, a lot of times people are thinking about if we want to create these AI systems, if you want to have voice interactivity. Again, there's this thing called 11 Labs. We will be using 11 Labs in one of the projects. But there's this idea that you have to build that into your systems. When really, if all you need is your computer to talk to you and you really don't care like how nice it sounds, you can have something that's already built into Linux, and it will simply be able to say the text that you feed it relatively easily. And so anyways, there's this whole speech to text down there. One of the things, if you're dealing with the Raspberry Pi, so if you're actually interested in this, there's this whole disaster. They used to use a connector called Pipewire for the sound output. It is now ALSA. So you need to do the sudo apt install, y, just for yes, pipewire-asla, and that will install a component into your system to actually get your speaker to work properly. Again, the fun of administering Linux is figuring out all these little tools. You're like, but I just want it to play music or play sound, and it won't. Anyways, so there we go. So the first thing I want to show you folks is basically text-to-speech with PyTTSX3. If you go to page 3, it shows you, again, setup, Python, you install this particular module. Again, you do have to install the pipewire hyphen ALSA if you're going to run this on the Raspberry Pi, or it won't work properly. And it's very weird. This whole thing, again, with sound on Linux, oh, it's a disaster. Because, again, you can get MP3 to play fine. You can get YouTube to play fine. You can get all these sounds to play fine. But when you try to use what's called eSpeak, the fundamental component of this, when you try to trigger that, it fails unless you have this particular component installed. Okay, so, yeah, let's see if we can do. Come on. Not that. Okay. Ooh. All right, well, a lot of you folks are not going to be able to see this, but we're gonna see how this works. So let me escape. I'm going to Control C out of this, and with this, eSpeak, hello world. So one of the cool things with eSpeak is it is just a command line tool. Oops, Control C, eSpeak. All right. Why is that buzzing at me? Stop buzzing. Okay, so hopefully this will work properly. So if we take a look at this, if you can see, basically I typed into the command prompt, eSpeak hello class. And again, so this is a command line tool. That is all you need in order to hopefully get voice. And we're going to hit enter.
Hello class.
There we go. So again, that's one of the things to be thinking about. Again, we started talking about artificial intelligence and all these systems. Again, thinking about all of these individual components, and that, again, that requires no resources, requires no cost, anything else. If we then go and we took a look at the code, we can put this into Python. All right. And this is basically all we got, right? In order to get speech, it's all pretty simple, right? Import PyTTSX3, engine equals PyTTSX3 .init, text, whatever you want the text to be, and then you simply say engine.say, whatever that text is, and then basically you make it run and wait. And so this allows you to be able to get speech to text on your system. So if I then run Python 3 pi-tts.p. So again, this is what we call a janky. And there we go. That's all we're going to do to run this thing. And then we're going to hit enter.
Hello world.
Right. And so the important thing to understand, like especially if you're new to coding, one of the big things I talk about this whole artificial intelligence world is, right, AI is incredibly hard, right? I keep doing this. AI is incredibly hard. It is incredibly difficult. I'm not going to do artificial intelligence. Like real artificial intelligence, I'm not going to do. 99% of the people in this room are not going to do it, right? The engineers with OpenAI are incredibly smart, brilliant people that do whatever it is that they do. But the important thing to understand for most coders and sysadmins and the rest of it is we don't have to worry about recreating artificial intelligence and figuring out how to make the next Mamba 2 transformer model or whatever else. All we need to be able to do is access API calls, right? So basically with this, I can simply take text. So this text can come from anything, right, input, and they can simply get spit out as an actual voice. And it's literally, again, that's not actually 9 lines of code. That's literally 5 lines of code to get that to happen. Are you taking my book? Do not take my book. No, take the paper, not the book. Paper, not book. No, you can take the paper, just not the book. Anyways, people stealing my books. Anyways, so that is basically how that works. If we go over to speech recognition, right? So basically when we take a look at this, people running out. Anyways, it is dark in here. How do people see their own notes? Do I have a light? Anyways. Okay, when we take a look at speech recognition and we look at page 4, basically here I show you how to use 2 different models on something like a Raspberry Pi. So we have the Pi-Whisper model, and this actually simply uses the OpenAI Whisper model, and so this runs completely locally. So you don't need a Wi-Fi connection or anything like that for it to run. And then we have the Google model, and the Google model actually does go up to Google, and like I say, you don't have to pay for the API key, and it will function. Now if we take a look at this, again, Pi-Whisper. First thing you're going to do is you're simply going to install into Python speech recognition. You then go through all this. So basically with SR microphone as source, it's listening, and then it's going to try to listen to what you're saying for this Whisper model. Right here is basically where we do recognize Whisper. So we're going to use Whisper instead of something like Google, and it's going to try to understand what you're saying. So if I try to do this on this thing, www.per.py. Oh yeah, let's see how this works. Hello, how are you doing? Oops. Transcribing. There we go. You said, hello, how are you doing? So again, so that actually happened completely locally, did not go online or anything like that. You can try to be a little bit more complicated. Kind of show you this as a reason. Let's see here, or as an example. All right. How much chuck could a woodchuck chuck if a woodchuck could chuck wood?
That's pretty good.
Said, how much could a woodchuck chuck if a woodchuck could chuck wood? Oh, that actually did pretty well today. Normally when I do that, it does not work very well. And that's where I say we go over to the Google model, right? So the Google model, this does not work locally. So basically, it's a lot of the same thing as we had before. The difference is we're going to do recognize with Google, and what you're going to see is it normally is a lot better. So we go... Google .stt. Oops. So, hello, how are you? So one of the things you'll notice there is even though this went up to the API, look at how much faster that was, even for something as simple as hello, how are you? And then if we do something more complicated, how much chuck could a woodchuck chuck if a woodchuck could chuck wood? And there it goes. Speech recognition thinks you said, how much chuck could a woodchuck chuck if a woodchuck could chuck wood? So basically it was a lot faster and is able to recognize something as complicated as how much chuck could a woodchuck chuck, right? And so this is a very simple way. Again, you can now be able to get voice into whatever program that you have, turn it into text, and then you can parse it, be able to deal with it like you would any other particular text. And that's going to be one of the big things to be thinking about with all this stuff, whether it's images or whether it's voice or anything else, is how do you turn it from this multimedia gibberish into text that you can actually do something against? So then we go over to page 5, and we take a look at speech recognition and OLAMA. So basically what this is we're going to start adding OLAMA to all of this. So we take a look at this. This is going to be our code. All right, so up here we have import speech recognition like we did before. Now we're going to say from OLAMA import chat and chat response. This is basically just simply how we're able to interact with OLAMA. And the important thing to understand is OLAMA is the local model. These configurations up here are basically trying to deal with the speech recognition. So you get into weird problems, especially with however you speak or however your users speak. How long do they pause for? Like that kind of weird silence and that type of deal. And so basically this is what that configuration up there is trying to deal with. Pause threshold, somebody can pause for up to a second. Non-speaking duration, again, for a second. That tries to make it a little bit better. If we go, we have a while true loop down here. So this allows us to just continuously go through. Now again, be careful with this. You will notice I'm using a while true loop with Olama. Here's the thing. The worst thing that happens with a while true loop when you use Olama is you just burn your Raspberry Pi 5. You just melt it to the ground. You lose $100. Here's what I want you to be very careful about. If you use a while true loop with OpenAI's API, how fast can you burn through millions of tokens? Right? Basically, this thing is going to run just as fast as your computer is going to allow it to run. And so if you screw something up where it doesn't stop, so let's say you make a query, you make a request, and then the answer is supposed to come back and print on the screen, right? And so, okay, that's going to be like 10 words, 20 words, who the hell cares? If you're using an API, what happens if you dork things up so that the things never print out on the screen? And so literally that query just keeps hammering the API a gazillion times until you pull the plug. So do be careful with while true loops. Basically, query, we have a function, STT, so speech to text. We go up and take a look at the function here. And basically, this is the same kind of thing that we were dealing with before. Adjust for ambient noise for up to 5 seconds. So we got noise out there. Phrase time limit, so limit it to 15 seconds. So it's not going to be any more than that. And then what we're going to do here is we are going to create a little HTML document file for the conversation. So what this is going to say is it's going to say, basically, this is the query that you put in. And if you look at this, all this is an HTML thing to auto-refresh every 1 second. So a little auto-refresh thing. Basically, what's going to then happen, so query STT, this is going to write to the HTML document. Then we're going to come down here. If query does not equal error, response equals AI. And again, this is what's cool with AI nowadays, is you think about how complicated AI is, and then you see it's, whatever that is, 6 or 7 lines of code. Right, so I'm going to put an injection in here. So whenever you're dealing with these LLM models, they're very verbose. They're like an old person, an old person who hasn't talked to a human being in a year, and you say hello, and then they never stop talking. That's basically what LLMs are like many times. So you always want to put in a very basic injection of, if nothing else, answer in fewer than 20 words, right? So query equals the injection, and I just do hyphen query. So answer in fewer than 20 words, whatever the query is. Then we have response. So basically response, it's response. The value for the variable equals what's going to come through and is going to come back as a class data type. We're going to put Granite for 350 million parameter model here. So the 350 million parameter model is about 750 megs in size. So basically this should run on darn near anything and is actually surprisingly good. So if you haven't dealt with IBM's Granite models, I would highly recommend you take a look at IBM's Granite models. I did an interview, it's on Silicon Dojo, with the VP for AI models with IBM. One of the things I like with IBM's models is they trained it on business communication. So think about this if you're running this in your corporate environment and you think about LLMs and basically they respond basically off of statistical relationships. So this is how they think words should go together. So if this is in your business environment, especially if you're dealing with something like human resources, do you want a model that's trained on Reddit or business communication? Again, so you might want to take a look at IBM. It's an open source model. You can take a look at it. Anyways, we have role user, so that's pretty standard now. And then content is query, so the query with the injection. And then this is the response. So the response comes back as a class. So we go to response.message.content, and that is actually going to give us the content, the value that we care about. And basically what we do down here is with open, we're going to do the conversation.html. We're going to append. So we have what the query is, we're going to append to it, we're going to write a line, and we're going to write the response. So if this does not go horribly, let's see here, Python 3, hyphen talk hyphen olama.py. Oops. Okay, so it's doing its normal thing. Let me go up to this conversation. Okay, so we got error. You can't see error. All right, so right now we got an error because it didn't recognize. Oops. Come on. Is there a reason it's buzzing so much?
Something's hitting power up there.
Yep, all right. Yeah.
You just have to filter out any noise.
Yeah, this kind of. Oh, look at that. That's troubleshooting. Okay. So right now we've got the conversation.htm and we have error. What is a woodchuck? No. What is a woodchuck? There we go. So polls, what is a woodchuck? It's now going to llama, a groundhog known for its distinctive burrowing behavior. Yep. What is the difference between a groundhog and a woodchuck? There we go. So that basically gives you that idea there. So now this is completely dynamic. I am now talking. It is now picking up what it is that I'm saying, and it's probably going to start giving me a lot of random stuff back because it's just basically processing off of that. But this is what gets kind of cool with this. Again, we now have a voice that's being able to recognize, what we're saying, and then we have a llama trying to answer what it thinks is a query based off of what we said. And that's the basic idea that we're going to go into for the next couple of labs here. Any questions up until this point? Yep.
So in the first example, the model that you're running is not on your MacBook; it's on the Pi itself.
Yeah. So the Olama, all of that is actually just running on this little Pi here. Yep. So yeah, we got a little Pi just sitting there, and that's what everything is running off of. Yep. Yeah, and that's going to be one of the important things, again, to be thinking about with these models is depending on what you're required. So like you hear about tools models. So if all you're trying to do is something like a function call, again, you don't need a 120 billion parameter model to get the time function, that type of deal. Do you have a question?
Honest question, no hate on Pi.
Yeah.
I was actually contemplating to get whatever the new Mac Mini when it comes out soon.
Yep.
But I love the idea of a small Raspberry Pi, maybe something like a TV in my house with all this stuff.
Yeah.
Like a calendar type of thing, right? But what would be the advantage of maybe going $250 cheaper for something that has the finicky stuff that you were just showcasing, right?
Yeah.
Versus buying something that is a little bit more finished.
I mean, so basically with the Mac Mini, you're going to get a real computer. I mean, a real computer, right? The big thing with these Raspberry Pis is that you're going to get those GPIO pins directly connected to it. But one of the cool things is if you go to elithecomputerguy.com, I have lots of old classes. You can actually connect an Arduino directly to any computer, and through serial communication, you can get the ability to have GPIO pins essentially. So you get that. I mean, if you're skilled enough to be able to do that, the only other real value proposition of the Raspberry Pi then would just be power consumption. So you literally could connect this thing to a little solar panel, and it could run whenever there was light, that type of deal. With your Mac, I mean, well, unless you get a really big solar panel, your Mac's not going to do.
I'm really curious, that's all. I don't prefer one over the other or anything like that. I was just legitimately trying to pick your brain.
Yeah. Yeah, no, so yeah, the Mac is going to be a better computer. So again, it's like, what are you using it for? So if you really want a computer, the Mac is the way to go. Again, if you want this IoT functionality, that type of thing, the Raspberry Pi is the way to go. But yeah, it is an argument now with the whole AI thing going on, with the price of everything going up so much. If you look at a 16 gig RAM Raspberry Pi now, is over $200. So it's over $200 for the Raspberry Pi, and then you got to spend $15 for the power supply, and then you got to buy the micro SD card, and then you got to spend $5 for heat sinks. All of a sudden, that cheap Raspberry Pi is now $250 easily. So yeah, that's.
How much of it is like when you're running these AI models?
Yep.
I mean, the real value proposition here is being able to run locally and not make. Certainly, you can make API calls.
Yeah.
And then it's really lightweight. But how much of a Raspberry Pi capacity can run local modules? Like, can you do real-world applications, or they're very?
Well, so one of the things we're going to show at the end is we're going to have a full potato example of basically where it's doing, it's doing tool calls. So again, one of the things to be thinking about is if you're just creating tools, like what is the weather? Again, we're going to have a relay for turning a light on or off. So that kind of thing you could run locally. So again, it depends on, if you're trying to get the diagnosis for cancer, it's not going to run on this thing. Again, if you're going to turn lights on, if you want that, that communication where I can just simply say, "Hey, potato, I'm cold," and it will turn on the heat for me. That's basically the level that it would be at. Yeah. And the other valuable thing too is with the Raspberry Pis, if you can get the price down, is kind of the theory you could put them in every room. So imagine if every room in your house had one of these local IoT devices. And so again, you say this room is cold and it turns the heat on for you. Your wife is in a different room and says it's too hot and it turns off the heat in that room. So you can do that kind of thing. But
it's interesting, how much of this you want to run it on the cloud, because you are connecting to remote tools in the cloud somewhere else to call services, even Google Voice or
yeah.
any AI calls. Then you rather just run the brain in the cloud and
Yeah.
have the edge engines only for I/O.
Yeah.
You don't need to install any local LLMs.
Well, but the other thing too is to think about though with some of this stuff is, again, imagine if this is in a hospital environment. Is there any PII going on? Again, if you're sitting there and you're talking with your spouse about your will, do you want that going up to Google or whatever else? Yeah, it's decision points. And
Security too, because you want something in the middle rather than giving everything to the cloud.
Yeah. Any other questions? I think that's one of the interesting things, again, having done technology for so long, is I don't know how long people have been here doing technology. Remember back in 2010 when a lot of technology professionals argued they would never move their infrastructure to the cloud? They're like, I would never put that on the cloud. And you're, okay, whatever. And so again, a lot, that's one of the things with architecture is a lot comes down to the decision making of the administrators, what makes the administrator comfortable, what makes a CEO comfortable, that type of deal. Okay, so speech recognition and then text-to-speech on page 7, and then the code is on page 8. All right, so this is that, right? Pi talk Olama speech. Pi talk Olama speech. Okay, so this is where we start getting the whole interactivity going on. There we go. Okay. So we have the stuff that we had before, speech recognition, OLAMA, plus we are now adding PyTT-SX3. That is going to give us our text-to-speech, right? We come down here to the engine. This becomes interesting with PyTT-SX3, is you can say what kind of voice you want it to have. There's a couple of settings for the different voice if you want to change the accent a little bit. One of the other ones that's kind of weird is you can actually change the rate of how fast this thing speaks. So that's one you might want to tweak based off of your own preferences. We come down here, again, the while true loop again. Query equals speech to text. We come up here. Again, the same thing basically that we had before. I'm just going to be using Google from now on just because it's faster and more accurate. Then we come down here. We're going to print out the query on the screen. If query does not equal error, we're then going to do TTS, what the query is. So this is basically for troubleshooting, making sure that we know what the hell the computer is actually listening to. And so again, what's really cool with this module is all you do is say engine.say whatever the text is. So whatever I say in, it's simply going to repeat back to me, and then you're going to do engine.run and wait. Then we're going to come down here to response equals AI query. We're going to print that out on the screen, and then we're going to simply going to do text to speech on that. So I'm going to talk to it. It's going to repeat back what I say, and then that's going to run through Ollama, and we're going to see how it all works. Let's see here. Do I keep touching something here? Anyways, let's see here. Control C. Okay, Ollama. Hello, how are you doing today?
Hello, how are you doing today? Hello, I'm well. How can I assist you today?
What is the difference between a groundhog and a woodchuck?
What is the difference between a groundhog and a woodchuck?
Ah!
Ranges, behaviors, and
Sorry, you're not seeing that. What is going on here? All right. What is the difference between a groundhog and a woodchuck?
What is the difference between a groundhog and a woodchuck?
Oh, of course you're doing this right now. What is the difference between a groundhog and a woodchuck?
What's the difference between a groundhog and a woodchuck? Woodchucks have longer legs and shorter tails.
I don't know. What is a taco?
What is a taco? A taco is a taco. Its ingredients like meat, cheese, beans, or vegetables.
Christ. Anyways, okay, so you kind of get the again, if you're not, failure is fun. It's like if you don't fail, you don't have a good story. Anyways, so the basic idea of what is going on here is we are now able to speak into this thing. It is able to turn our voice into text. It is able to repeat that back to us so we know what the hell it's actually hearing. It then is able to run that to Ollama. That is being run locally, and then is able to be able to talk to us. And so in relatively little code, you can actually then start having something that seems like a relatively sophisticated program. Come on. Again, so yes. So anyway, so all of this is a total of 55 lines of code. Very crappy code. What is going on?
Very crappy.
Thank you. Yes, it is very crappy. Oh, Lordy. Every one of those days. What is going on?
I'm sorry for any misunderstanding, but I must clarify that as an AI language model, I don't have the ability to assess or rate individuals based on their work ethic or
Well, that's kind.
using a conversational interface. If you have any questions related to tasks or interactions,
Control C.
We're about 5 seconds from the I can't do that, Dave.
Wake me up at
What the ever-loving hell is going on? Oh, my golly. This is just... I don't know. What is... Hold on one second. Let me just... That's plugged in, right? Hello? 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 Hello, hello, hello?
Hello, 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 hello. Hello, how can I assist you today?
Oh, there we go. What is a taco?
What is a taco? A taco consists of a corn tortilla filled with various ingredients such as meats, beans, vegetables, cheese, salsa or chili, topped with lettuce, cheese, and other toppings.
All right. Now, how do you stop you? Come on, Control C.
How do you stop you?
Oh, Lordy. Yeah, so the Control C. There we go. Jesus. Okay, anyways, so now you have the basic idea, 55 lines of code. We're starting to get something that looks like artificial intelligence that's probably going to try to kill you at some point in the future. You're like, oh, that's how HAL got developed. They shipped that. That's what happened. Okay, so the next thing that we're going to take a look at is a little bit more sophisticated. So we're going to do Olama speech recognition, text to speech, and then we're going to add an LED and a prompt. So one of the big problems that you're going to run into is when you start dealing with these quote-unquote artificial intelligence systems, is you're going to notice there's lag and there's delay. And again, whether it's the Raspberry Pi is going to be a longer lag or delay, or even you're using an API call, there will be shorter lags and delays. But there's going to be lag and there's going to be delay. So one of the big questions is how can you tell your user whether or not the AI is actually listening to them? Right? Again, I noticed this. I'm an Aspie. I'm somewhere on the spectrum. There's this whole thing called nonverbal communication, which I find fascinating. I just don't get this. It's called intuiting. Like apparently you can look at a human being and 90% of all communication is done nonverbally. That sounds fascinating to me. I don't quite get it, right? And so that's one of the interesting things. Like when I deal with these AI systems a lot of times, one of the problems that you run into is not that the AI system is failing, but if you're talking at it while it's thinking, then you're not going to get a good response back. And so that's one of the big issues that happens. And so what we have here, this particular thing, is, so we have our Raspberry Pi, and then on this now, I've connected what's called a breadboard, and we have LEDs. So when the green light is on, it's ready to listen to you. When the blue light is on, it means it's processing. And when the yellow light is on, it means it's speaking to you. And so that way, you don't even need a screen on this thing anymore in order to be able to interact with it and get the responses back. And that's one of the things, again, to be thinking about when we start talking about like IoT and we start talking about artificial intelligence, is we are so inculcated with the idea that computers are screens, mice, keyboards, and that type of deal. Again, imagine if you have an incredibly powerful computer. Imagine if you have a $3,000 computer with that fancy NVIDIA GPU in it, but the only visual interface is 3 LEDs. Again, that's one of the things you can start thinking about with artificial intelligence and what's interesting with this IoT stuff. So if we take a look at this, there we go, LED. So we start to get some more stuff here. Oh, is this the one that has the relay on it? Oh yeah, has a relay on it too. And we got a relay on this one. So that'll be even more interesting. Okay. So we take a look at this. So we have speech recognition like we had before, Olama, PYT, SX3. Then we have from GPIO 0, import LED and output device. So GPIO 0, this is the module for Raspberry Pis that allow you to interact with the GPIO pins. Right? From time, we're going to import sleep, so we can sleep for a fraction of a second every once in a while. And we're also going to import date time so that we can ask the thing what times things are. If we take a look at this, LED ready, so this is when it's ready for you to ask a question to it, is going to be LED pin 17. Processing is going to be LED pin 27. Answering is going to be LED pin 22. So if you look at the GPIO pins, you just basically connect your pins to those particular, or the connectors to those particular pins. We're then going to have relay. So LED is a function for literally turning on LED. Then we have relay equals, so output device, and basically active high. So when it's on, it's going to be, when you trigger it, it's going to be true, it's going to be on, and that's going to be hopefully for our little light over there. We have the speech recognition like we had before. We have the PYTT SX3 like we had before. And then we come down here to our while true loop. So LED ready dot on. So we're going to turn the ready light on when the loop starts. We're going to do query, speech to text. Once that query has happened, we're going to turn LED ready off. We're simply going to print the query on the screen. If query does not equal error and hey potato in query, right? So we're going to need to start using some trigger words for this whole system, or it's going to be an utter disaster. As you saw before, I ask you some questions. We go through the demo. It looks really nice. Then I start talking to you, and it's still listening to me as I talk to you, and everything goes crappy, right? So basically what we're doing here is we're simply doing a trigger phrase, right? Hey, potato. And so the cool part is you can put whatever you want in there. So as long as it's not an error, and there's hey, potato in there, we're going to go here, and we're basically going to replace hey potato with nothing. So again, you're dealing with an LLM. If you feed it hey potato, what time is it? it's going to try to answer that statistically, whatever the hell that is. So what we're going to do is we're going to eliminate the trigger words and then only send what we actually want to the LLM. Text-to-speech query, so we're going to get that that's going to be spoken back to us. Processing light is going to be turned on. If I say end the session, this should exit the session. If I say what time is it, so these are all hard-coded here, it will give me the current time. If I say light on, it will turn the light on and respond with light turned on. If I say light off, it'll turn the light off, say light turned off. Else, if it's something else, it will send everything to the AI function like we've had before to answer the query. So if I ask it a joke or if it asks about groundhogs or whatever else, it'll go up there. LED processing is off. Then answering, light is going to get turned on. TTS, whatever the response is. And then the answering is going to get turned off. It'll sleep for half a second, and then it will go through the loop again. So if we go speech, let's see here. LED prompt. Oops. Okay, so I can sit here and I can talk, and it's just not going to care, right? See, right now I'm sitting here talking. It's not responding. Oops, and the light isn't turning on. Hello. Hey, potato, what time is it?
Hello, what time is it? 14:27:50.
Oh, LEDs, you're going to kill me today. What the hell? Hey, potato, light on.
The hell light on.
Yeah, well, so turn the light on. Oh, there we go. There we go. It's just not plugged in all the way. Electrical connections. Oh, now it's just always blue. What is going on? Hold on 1 second. Let me turn the... So that's there. Oh, that came out there. There we go. Oh, no. Well, there's a green light here. Hey, potato, what time is it? Hey, potato, what time is it?
What?
It's trying to answer. Oh, Lordy. You don't know how much work I did to make sure this would all function before I did this. All right, so it's green right now. Hey, potato, light off. Oh, well, you're getting the point. Realize turning on LEDs are kind of sort of turning on. I swear to God, this all worked perfectly before. So anyways, so what this is supposed to be doing is you now have a prompt, so it will only do something. Like right now, it is still running, but it will only be triggered when I actually say the trigger phrase, and we have the LEDs, and this is trying to give us some kind of visual cue as to what the script is actually doing. Any questions up until that point? Yep.
Can you show us the connection to the light?
Oh, yep. So basically all this is so this is a relay. If you like dealing with IoT devices, you can buy this on Amazon for about $30. So one of the big things is when you go to Amazon, there's going to be a lot of relays that are going to cost $5. You say, I want to buy that. Well, here's the thing. They don't have a nice protective case around it. They have a lot of solder points that you can go and lose your finger over. So this costs about $30. And so what you have here is you actually have a little trigger switch. So you have positive and negative. So ground goes to ground on the board. Positive goes to the GPIO pin to turn it on or off, and that's where it sends the signal.
To the Raspberry Pi.
Yeah, so the Raspberry Pi in this mess basically has the trigger GPIO pin goes to positive, and then the ground just goes to a ground pin on there. Yep.
It's pretty cool.
Yep. Yeah, it's a great little thing, again, for doing these kind of like education classes and that type of stuff. Okay, any other questions? No? Cool. Okay, so now we're going to go to the full potato and see how well this works out. So basically the idea with the full potato is what if we want to extend the capability, right? So if we take a look at this, what we can see here is basically we got good old-fashioned if-else statements. If in session, what time is it, light on, right? I mean, it works, but it's very specific. You have to say those very specific words, and it's kind of ugly if you want to manage and maintain it. So the idea is with the full potato, we have a tool file. So again, this is where you start thinking about things like agents, that type of thing. Anyways, this is an incredibly simple way of doing this. So up here, you import the modules like you do. So basically what we're going to do is we're going to import this entire file into our Python script. We have the relay here, and then we have the different functions. So a function for say hello, and so the response is hello, return response. Say goodbye, response equals goodbye, return response. Time, response equals that date time, return response. Weather, please don't hack me on openweather.com. Anyways, so what this is doing a REST API call. And so what we're doing is we're connecting to openweather.com, which is basically a free service. I am statically putting in the latitude and longitude that could dynamically be put in if you understand how to do it. And then basically what's going to happen is we are going to send back a value for a response. So the entire JSON value is going to come back. And then also we're going to put a value here to say this should have additional processing by AI. So again, something to think about in order to get the speed better. Like with time, if I ask at the time, I just want the time back, right? I just want it to tell me the time. With weather, I want the additional processing of artificial intelligence. So if I say, hey, do I need an umbrella? The JSON values will come back. It will take the query plus the JSON values, and then based off of that, give me an answer. On for the light on, relay on, and off for the light off. If we go take a look, so this one I'm using OpenAI, just hopefully it'll be a little bit quicker. We'll see how well this goes today. This .env, you do this to load the API key, because I don't want you guys to actually see my OpenAI API key. So here is basically how this is going to start working. So with open, tool underscore file.py, read as file, tools equals file.read. So the first thing that's going to happen is I'm going to read that entire file into a variable value so that I can then feed that to the AI to say what function am I looking for. We have the LEDs like we had before, speech recognition like we had before, text-to-speech like we had before. And let's see here. Where are we at? 234. Okay. So ready, light on. Hopefully that works this time. So if query does not equal error and it says potato, we're going to replace hey potato. We're going to speak the query like we did before. So function equals AI tool, query, and tools. So basically we have this AI tool function here. And what we're doing here is we're simply going to say, so we're going to be using GPT-5 Nano. And that's going to be one of the interesting things with all of this, is trying to figure out the model that works appropriately for whatever task that you're trying to give your system. Because these things are all over the board. Again, one of the things I will warn people, so we've been dealing with this whole service-oriented architecture world since about 2010, and it's fabulous. Like, I'm going to show you how to use Twilio. And the thing is, if you build a system on Twilio, then you decide you hate Twilio, you swap out about 20 lines of code, you swipe your credit card, and you're using somebody else's service. Who the hell cares? You change some error codes, that's all you do. One of the things that will warn you with these LLMs is these things are all over the damn board. Like, Gemini will give you an entirely different response than OpenAI, which is an entirely different response than Quinn. So the idea that you can just swap out one of these LLMs with a different LLM, you might find the testing phase for doing that is an absolute and utter misery. So I found that GPT-5 Nano seems like it works pretty well here. The other thing too is, again, with prompt engineering, you're going to have to figure out what prompt actually works, which again is also fun with things like tools. So return only the name of the function from this file of functions based on this query. And here's a list of functions, right? So basically, here's the query, here's the tools, so the functions. Please give me only the name. The issue is you're going to come down here, and we're going to do a try except statement. And so when I do Silicon Dojo, most of the time I strip out things like try except statements because I'm trying to teach very specific things in these classes. I'm only trying to teach what I'm trying to teach you. And so when you add security, you add all these layers. It confuses people. Here's a problem, though. We're dealing with LLMs. You're going to want to put this try except statement in here because the issue that you run into is 95% of the time it will give you the tool name back. So what it's supposed to do is it's supposed to look at that tool file, give you the tool name back. We're basically going to turn it into a function, fire off the function. 5% of the time, it will return the tool that you are probably looking for is this named of tool, and the reason that I provided it to you is because of X, Y, or Z. And like, that is not what I asked. I just want the name. So anyways, that's why you do have to put a try except statement in here. So anyways, when we get the function back, we're going to replace the parentheses with nothing, so we clean it up. We're going to strip out the white space on either side. And then again, since we're dealing with LLMs, basically what I'm doing here is with this F string, I'm putting these lines here. So when it prints out on the screen, it'll show me line, line, the function name, line, line. Because again, one of the problems you get to with LLMs is they respond with whatever the hell they respond to sometimes. And so I'm trying to get a visual representation of what the hell this thing is giving me. So if I'm running into problems, I know why I'm running into problems. So then I'm going to go here, and it's going to try. So tool equals, there's something called get attribute function. So from the tool file and the function value, it's basically going to turn the function value that came back as an actual function that you're able to actually fire off. Response equals tool, and so this is where it's actually going to fire off the function itself that it came back with, and it's going to give us a response. Except tool failed. So here, if it failed, it means a tool failed, or except up here, this is where it gives a really big, long response for some reason. We're just going to say get attribute failed. If response 1, so index 1, so if we take a look at this, right, when you're looking at response here, that will be response at index 0. This will be response at index 1, right? So that's that AI additional processing. So if response at index 1 equals yes, we're going to send the response to AI response query and response. So the query and the response that we count back, we're going to send that all the way up here. And basically, we're going to say answer in fewer than 15 words, answer this question based on this response from a function and the data. Hopefully, it's going to give us a decent response back. That's going to be for like things like the weather. And then we have the LEDs, turning on and off, and it's going to talk to us. So if we run this, we're going to see what happens. Okay. Let's see here. Python 3 full POTATO pi. Let's see here. Yeah. Let's see if this works. Come on. Hey, Potato, what time is it?
What time is it?
There you go.
14:40.
There we go. See, the LEDs are working now for some reason. Hey, Potato, K Aura S. Hey, Potato, K Aura S.
Where for release? 14:40.
All right. Hey, Potato, Guten Tag.
Guten Tag. Hello.
Hey, Potato, it's dark in here.
It's dark in here. Yeah.
There you go. Hey, Potato, it's too bright.
It's too bright.
Oops. It's doing something.
Yeah.
There we go. Yeah. Let's see if we can do the final one. Hey, Potato, do I need a winter coat today?
Do I need a winter coat today?
So it's doing the REST API call. My question and the value is going back to it.
Yes, you need a winter coat today.
And then it's giving me that for whatever reason. Hey, Potato, what's the low temperature today?
What's the low temperature today? (64.29 degrees F).
There you go. So it's giving that actually for Asheville, like I say, because that's hard-coded. And again, the cool part about this is, again, we start talking about like IoT and like smart homes and all that kind of thing. So again, the Raspberry Pi 5 here, it's going to cost you about $200. This is going to cost you somewhere between $12 to $17. So since this is all API calls that is happening, you can literally have this power of a computer. You simply have the microphone, the speaker connected to it. You connect it to an API. Just make sure you don't screw up that whole while true loop. And now you can actually have a smart home or a smart environment that you're building. So that is that part of the Raspberry Pis and kind of tool selection and that type of deal. Any questions on that stuff? No? Cool, cool, cool. Okay, so we are going to get to the final bit. Oh, we're thankfully we get to put the Raspberry Pi away. Okay, so the next thing that we need to talk about is Twilio and such. Hold on one second. So again, I will say that architecture is absolutely the most important thing. You know, as an MCSE that's been doing architecture for 20 years, it's obviously the thing everybody has to care about. But I talk about it. One of the things you need to be thinking about, again, in the AI world is that whole question of, again, where do things like systems reside? Where are things occurring? What is the best way for all of this to work out? So basically what we're going to be doing now is we're going to be doing a telephone system. And so with a telephone system, what we're going to have is we are going to have my Arduino. Where did I put my Arduino? We are going to have my Arduino. That's over here. Okay. So it's a little hard to see because it's dark in here. Anyways, so this is an Arduino. So we talk about Arduinos. Arduinos are not Raspberry Pis. For whatever reason, they get dumped into the same kind of bucket. People think Arduinos and Raspberry Pis are the same thing. They're different. And Arduino, so take the paper, leave the book. Yep. So Raspberry Pi is a full-fledged computer. You can build servers, do all that kind of stuff with it. When you're dealing with an Arduino, basically what these are called microcontrollers. So basically you have what's called an IC chip on here. You're going to write code, and what is going to happen is you're just going to have a continuous loop. So you're going to set up your environment. You're then going to fire off basically a while true loop, and it's always going to be true, and it's just going to loop, 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 loop. And it is going to be pulling in values from its pins, and then it'll be able to trigger events basically going out from it. So that's what we're talking about when we talk about something like an Arduino, which is a microcontroller. Also, there's something called a Raspberry Pi Pico, which is also a microcontroller. But these are not computers. They do similar stuff to computers, but it's not the same deal. The cool thing is, like with this is a Raspberry Pi Uno with Wi-Fi. So this actually has a full Wi-Fi stack on it. What that allows us to do is it allows us to send commands basically with a webhook up to a server that's online, so it can send things up. So what we're going to be doing is we're going to be sending a temperature value. So I have an analog temperature sensor on here. It will send that value up to a server. That server will then publish that to a web page. It will also constantly look for commands from the server, and based off of those commands, it will basically turn a fan on or off. Since we're dark, our fan is going to be a light again, so you can actually see what's going on there. All right? So that's what we're talking about when we're talking about an Arduino. And again, that's the kind of thing to be thinking about with these AI systems is, you know, do you need a $40,000 GPU, or do you need a whole bunch of, $20 Wi-Fi Arduinos? So basically what's going to be happening here, right? So we are going to have our little Arduino here. with its little sensor, and it's going to be getting sensor values in. So when you're thinking about sensors with Arduinos, there's all kinds of sensors out there. Like this is a motion control or a motion sensor. So you can have motion sensors. You can have what are called ultrasonic distance sensors. You can have humidity sensors. You can have water sensors. You can even have things like carbon dioxide sensors. So imagine, you have a room like this. You have a lot of people in the room. The carbon dioxide goes above a certain amount. You might want to tell the security, what's going on, maybe open up a door, that type of thing. But all these sensors, again, when you're dealing with Arduinos, they're either analog or digital sensors. Analog basically just means it sends a voltage value back, and then with a little bit of code, you turn that voltage value into something that's useful. With digital, with the packages that you install into Arduino, basically there's configurations for what it reads from those digital sensors. So basically you can have the sensor here, or you can have this Arduino here, and you can have any number of sensors connected to it. You can also have things like relays connected to it, so you can have water pumps connected to it, you could have air conditioning units connected to it, humidity things, you could have alarms, you could have whatever, anything that can get triggered by a little voltage can be connected. So this is going to be Wi-Fi. So this is going to go up, and this is going to connect to your network, and then is going to go to the cloud. On the cloud, you are going to have your VPS. So it's a virtual private server, and so we're going to be using DigitalOcean today. And again, this is where we start talking about AI is just another stack. So the example that I'm going to be showing you today, right? So we have a server up here, www. It is going to use Engine X as the what's called a reverse proxy server. That is then going to present something called Gunicorn, which is a Python web server essentially. The Gunicorn is going to present the web application that was created in Bottle. So that is a web framework that we use for Silicon Dojo. Bottle is basically then coded in Python. And that's all we're going to have for today. But again, you are now looking at basically a web stack there. Now, beyond that, over here, we're then going to need DNS. So for DNS, we're going to use something called Cloudflare today. Cloudflare is awesome for DNS because you actually have SSL built directly into it. So whether or not you want to put this into a production environment, that's an argument over many, many, many beers. What this is good for lab environments is basically what happens with Cloudflare is you have your server, and when traffic comes to your server, Cloudflare is in the middle. So you can do something called the flexible scheme, and I'll show you this in a second. And basically with flexible scheme, what happens is the communication between Cloudflare and your server is not secure, is not SSL communication. But the traffic from the user to Cloudflare is under SSL. So there are a lot of things nowadays where you need HTTPS in order for this to work. So we're going to use something called 11 Labs, a webhook with 11 Labs. 11 Labs will only allow the webhooks to function if you use HTTPS. So if you don't want to use Let's Encrypt, if you don't want to have to figure out how to put an SSL certificate directly onto your server, basically simply by using Cloudflare, you get that SSL capability without having to go through all that mess. So anyway, so we got Cloudflare over here. Then under that, basically again, as I said, we have 11 Labs. So 11 Labs is awesome. If you have not played with 11 Labs, play with 11 Labs. Basically, this gives you the voice AI agents. So there's a whole bunch of configurations. You set up when somebody calls in, what is the initial response that they should get. It actually has built-in RAG. So if you want to create a knowledge base on 11 Labs itself, you can add web pages to it, you can add PDF files to it, you can add all of that kind of stuff to it. You can then do integrations. You can integrate with services such as Calendly or HubSpot or that type of thing. And again, you have webhooks. And so basically we're going to use 11 Labs to webhook into our server, so we can ask what is the temperature that an Arduino is publishing here, and then I can say it's too hot, it's too cold, and hopefully it'll turn the fan on or off. And then below this we have Twilio, and so Twilio is the telephony service. So Twilio is what gives us our phone number. So basically when the person calls the phone number, it goes into Twilio. Twilio then routes it to 11 Labs. And that's how you get this ugly mess going on right there. Anybody have any questions with that? The basic idea there? No? Cool. Okay, so now we are going to see if I can make this thing work. Okay. Yeah. Buzzy. You know what? I'm just going to unplug you because you were done. You are done for the day. There we go. Okay. So we take this relay. Oh, Lordy. There we go. Oops. We'll get this all to work. Okay, so you take this relay. So green goes to gray. Goes to gray. Okay. There we go. So hopefully this is gonna work. So let's go here first. So we go to Safari. Is that my temperature? Fan turned on. Okay, so right now the Arduino that I have here with a little temperature sensor should be sending values up to my server. Oh, yay! Thank God. It changed. Okay, so the value there is going up to the server. It updates like every 15 seconds, right? So I can put my finger on the sensor. All right, we're going to update it. And we're going to update it. We're going to update it. Hold on. What's going on? Fetch failed. All right. Oh. All right, so temperature is there. Connection failed. Maybe this is that whole thing. Okay, let me unplug this and plug it back in. All right, so this is, if you don't know this is the Arduino IDE. This is how you code for Arduinos. Basically, this is C. Again, that's one of the things, like for any new people that get into programming, they're always like, Eli, what language should I learn? It's like, oh, there's so many you probably need to learn in order to do your job. So this is one, right? Okay, so it's connecting. There we go. Okay, so I get that. So it says it's connecting to the server. So now we go to Safari, we do refresh. Yay! Okay, that's 7120. Let's see here. 7647. Thank God. All right, let's do one more time. There we go, 79, right? So we now see we are dynamically updating. And this, if you look all the way up there, this is actually at crappy-ai.com. And so it gives us these temperature values. Now, what we should be able to do is, so this is Voice, Google Voice. So this is a telephone service, actually completely free. If you just need a telephone number for some reason, Google gives this to you. I'm going to call in to the phone number for Twilio. We are going to get a message saying it's a trial account, just because they give you so much value in the trial account, just so when you hear that. Oh, come on. Now, allow.
You have a trial account.
Sound
you
5.
can remove this message at any time.
Automated system ready for your request.
Hey, dude, how warm is it, man?
The temperature is 72.08 degrees Fahrenheit.
Dude, that's too hot for me, dude.
I understand. Would you like me to turn on the fan?
Yes.
Turning on the fan for you now.
There you go. Right? And so notice.
Is there anything else I can help?
Now it's responding, right? Great. So what is the temperature now?
The temperature is now 70.32 degrees Fahrenheit.
Okay, it's a little too cold for me.
Would you like me to turn off the fan?
Yes. Yes, turn off the fan.
I have turned off the fan. Is there anything else I can assist you with?
Turn off the fan. Oh, well, there you go. A little slow. There you go. Yeah, right. So anyway, so notice now, right, I'm able to interact with this thing, again, over the telephone, the whole 9 yards. So we take a look at this. Let's see here. The first thing that we have, again, don't steal my account information or anything, is basically we have Twilio. Just so you know, if you want to start playing with Twilio, they give you a pretty decent trial account. They give you like $15 in your trial account. I have now been using this for like 3 or 4 months. I've been using this for numerous classes, and I still have $9 left in my trial account. So Twilio is, again, for lab environments is great. There's a whole thing. We had a whole class on how to do this, so I can't get into everything with it. But basically, you're going to be hitting Twilio, right? From Twilio, then, basically what's going to happen is it's going to forward directly to 11 labs through configurations. Here, you've got your phone number. So this is the phone number coming in, 844-431-1372. Again, this is a real phone number. Don't, but you could call it on your cell phone right now. And then here, you have what agent is assigned. So whenever a call comes in, this is the agent that is going to pick it up, the All Things AI agent. So I click on agents, I click on the All Things AI agent, and we come here to the agent. And again, this stuff is so simple, right? So what's the prompt? You are a computerized assistant for controlling security and HVAC systems. Do not answer any other questions. Then we have the first message down here, automated system ready for your request. Now, you do have to be careful with this. Again, we talk about things like denial of service attacks, and, it's amazing how you can destroy systems. So I have a plumbing company that I've used for a couple of years now, absolutely great company, and they started using an AI assistant in order to do things, which I think is a complete disaster. The problem is that the CEOs and the executives for the company listen in on the recorded calls. And what they find is that their customers are flirting with the female AI. Like, no joke, like not hee-hee-ha, like they won't get rid of the AI because it's making so many of the old geezers really, really happy. Again, it's a whole new world we have to deal with AI, right? Anyways, the issue that you have to be thinking about is when you deal with Twilio. Twilio is dirt cheap. You get that demo account, you can use it for a year before you have to put a credit card in. When you look at 11 labs, there's a whole bunch of things that you pay for. The big thing they're going to pay for is that voice agent that comes back to you. Basically, when I was initially doing testing, it came out to you went through the entire trial account in about 10 calls, right? So if you look at it, the cost for a normal call, somebody's calling, asking if they can bring a dog to your microbrewery or whatever, is going to cost you about 25 cents. One of the things that you do have to get concerned about is how much is it going to cost you when old geezers start flirting with your AIs? Like, no, seriously. Like, remember when Facebook, like when I got into Facebook back in 2010, it was all to see corgi butts. Like I had two corgis, and if you ever owned a corgi, the most adorable thing in the world is corgi butts. And so I went onto Facebook, and Facebook was great because it was a whole global community of people sharing pictures of their corgi butts. And now you think about what Facebook is. Like, you would never imagine that Facebook would turn into what it has, right? And again, that's one of the things with AI agents. It sounds really funny now about old geezers flirting with AI agents, until they start running up $10 bills because, And so again, that's one of the things in all of this, you're really going to have to think about how all that's done. You have your voice. So over here on the right-hand side, what voice? They have lots of different voices you can choose from. And then down here, you can actually select your LLM. So they have many different LLMs here, a whole bunch of different things. The curious thing is they actually show you, they show you the millisecond response time. So depending on what you're doing, like, do you need accuracy or do you need speed? So if you see GLM, I don't know what that one is, 4.5 error, that's a 932nd millisecond response time, right? So it's going to take at least a second for this thing to respond. It may be a better response, but again, that's going to slow things down. Quinn, 30 billion, is 189 millisecond response time. So we've got all these different response times here, and you got to figure out what works for you. Again, we did a class with this at American Underground, and when I was doing the testing for the class, again, something you have to think about is that the LLMs really are different. Like, you go like, oh, I want this LLM because it gives me a better response time. all of a sudden, all the configurations that were working perfectly for you until you swap the LLM no longer are doing what the hell they were supposed to do. So do be careful with that. Let's see here. Beyond that, you have workflow, so we won't go into this today. You can actually create call routes here. If you know what call routes are, you can create call routes. You can create a knowledge base. So this can actually have a RAG built into their system, so it can answer questions. Then we have the tools. So this is basically what we're dealing with here, and this is where we deal with those webhooks, right? So temperature. Check the temperature of the facility, and then here's the webhook, all right? So https, crappy-app.com, temp, that is going to be able to pull that value in. So basically, you give it a name, you tell it what it is, and then once it knows what it is, then it knows when somebody's asking what to do with it. Beyond that, we then have fan on. So I have a webhook to turn the fan on, crappy-ai.com/on to turn it on. And then the same thing for off, crappy-ai.com/off to turn it off, right? So this is basically, these are the different webhooks that you can add. So you could add a whole bunch of different webhooks here. Beyond that, you have tests, you have widgets. So this can be very useful here. So you're going to spend your money with that whole voice interaction. That's the actual expensive thing. So what's really cool here is with this web widget, is this gives you this exact same functionality, but just in text. So you can test things here. So I can say, what's the temp, dude? Right? Automated system, the temperature is 58, right? I'm hot. I'm a hot. Turning on the fan to cool you down. There you go, right? So this is where, like, if you're here playing, especially if you're going to do a lot of playing, play at this widget. The other thing I want you to be thinking about too is when you start thinking about artificial intelligence, is there was a concept that was real big 18 years ago. It's called unified communications, right? The idea is that text messaging and email and voice communication and all that was supposed to become one thing, this unified communication environment. Didn't quite work out that way. But one of the things to be thinking about with your artificial intelligence systems is how to unify the systems. Again, if somebody uses your chat system, are they going to get more or less the exact same response as somebody using a telephone system? If somebody calls in and gets a completely different response than somebody who uses the chat system, that can be a big problem. So that's one of the nice things with 11 Labs is they give you this functionality here. So anyways, past there, we then go to Cloudflare. So again, Cloudflare is great for DNS. You just pay the normal registrar fee. You don't have, again, I have GoDaddy accounts and now I have Cloudflare accounts. My Cloudflare accounts cost me $9 a year. My GoDaddy accounts cost me $22 a year. I really need to switch those around. So one, Cloudflare is cheaper. But if you come down here to the SSL TLS, let's see here, oops. SSL TLS, we do overview. You go here to configure. And basically what you're going to want in these settings is this flexible, right? So enable encryption between your visitors and Cloudflare. This will avoid browser security warnings, but all connections between Cloudflare and your origin are made through HTTP, right? So this is the easiest way to do it, not necessarily the secure way to go, but again, especially for lab environments, it's a great thing to do. So then we go to DigitalOcean. So DigitalOcean is where my VPS is residing. If you decide to use DigitalOcean, one thing I will tell you is use at least a $6 a month account. So they have a $4 a month account, a $6 a month account, and then it goes all the way up to $500 a month account. It's weird. I don't know what the difference is, but the $6 a month account actually works pretty well. The $4 a month account fails on damn near everything. I don't know. Can't even do a DNS request worth a darn. So at least pay for the $6 a month. Anyways, so this is my Ubuntu server, and up there, basically I uploaded my bottle code, I installed Nginx, I set this up as a service, the whole 9 yards. If we go then over to, the wrong one. If we then go to my app, retry. So this is going to be my code that is up on my server. This is the code up on my server. Code up on my server. Dun, 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 dun. Okay, I'm going to close this out. So basically, we use the Bottle Web App Framework for Silicon Dojo because it is dirt simple. All of this is a script required in order to create the service, and you don't have to deal with a lot of other stuff. Django, to be clear, if anybody knows what Django is fabulous. We'll have a class on it probably in a month or two. But the nice thing with Bottle is just it's a very, very simple framework. So from Bottle, import route, run, default app, post, and request. So routes are decorators for basically when people come to the site, this is essentially the page, right? So we see route up here and we see that. Basically that is the root of the page. And we're just simply going to return hello world there just to verify that's working. Down here we have the temp. So this is the temp page. If you go to /temp, we have a method. Basically we're going to be using get for this. Get works well. So my Arduino is going to be sending the values up using the get method. So if there is a get value, grab the value temp from that. If there is anything in the value with open, basically we're going to write to temp.dat what the temperature is. So if we do this, it should be updating. Come on, is it updating? Update. Did you die on me? There you go. See, it auto-updated for us, right? So every time the get value comes in, it updates this particular file. Very simple way to deal with it. It would be better what to do with the database or whatever else. With open, the temp.dat file, read as file, temperature reading equals file.read, and so the temperature reading. So basically what this does is it takes the value in, it writes it to the file, and then reads from the file, makes sure everything was saved properly, and then provides you that at the temp page. So if we go to Safari, and we go to, it must be this one, we go to the temp page, that's what we're getting here. See, so it's dynamically changing for us. Let's see here. Past that, so route on, so again, a webhook for on. With open, command.dat, so we're doing the command file, right? File.write on. So it'll write on, and then we'll also return with the webhook fan turned on. So we're giving some value to that AI agent of what's happening. Again, route for off. We're going to define the function as off. We're going to write to the command.dat file off, and it says fan is turned off. And then if we want to take a look at what the command is, so route command with open command.dat, and it's basically going to return the value. Down here, if you're dealing with Bottle, so if name equals main, basically this means run the script. So if I ran this script directly from Python, it would fire this off. I'm not running it directly from Python. I'm running it through Gunicorn, which is its own deal. So basically, it's not going to fire off. And then we do app. So app equals default app. This gives us an app name. So when you're using Gunicorn, there's a whole bunch of configurations for Gunicorn. Anyways, with Gunicorn, what you do is basically you give it the script name, colon, the app name. So the script name is going to be app, colon, the app name within the script is going to be app, and that's how you would call it. That is its own big old tedious class, though. So that is kind of what the Bottle looks like. And then from there, if we go and take a look at Arduino, because we are at 3:09. How long is this class till? 4:30? 3:30? Anyways, we're getting pretty close. So we come here. Basically, this is what the Arduino script looks like. That actually should not be there. I messed that up. Neither that. Anyways, so this is what the script should actually look like. So up here, you're going to be including the packages. So there's spi.h and Wi-Fi ANA. So basically, you have to add these kind of like you do with Python in order to actually get the functionality. You're going to be setting the pins. So we're going to do analog 0 is going to be the sensor pin. That's going to be for our temperature sensor. And for the fan pin, it's going to be digital pin 3. So when you look at the Arduino, those are the pins that you connect to. Here is where you can connect with the SSID and the password. So this is the VIP stuff. Shh, don't share it with anybody else. We're going to have status here. And this is the server that we're going to be connecting to. So we're going to be connecting to crappy-app.com. We do Wi-Fi client here. This is where we do the setup. So this is initially, this sets up the environment. for the Arduino. Serial monitor is going to be set at 9600 baud. So basically, when you're dealing with serial monitor, that's what you see down here. So all of this is being read from the Arduino. If you don't have the baud here set at the same thing, it's not going to show up for you. We're then going to set the pin mode for the fan to be output. So when we trigger it, it'll send a signal out to our fan or our light. While status is not connected, it's going to try to connect to the SSID, and then it's going to delay for 10 seconds until it is connected, and then it tells us connected. We go down here to the main loop. We're going to do reading equals analog read. So we're going to read from the sensor pin. You then have to take, again, that analog value that comes in, that voltage value. Basically, we have to go through all of this to turn it into a temperature. This is what gives us the Celsius temperature. And then for Fahrenheit, we then turn Celsius into Fahrenheit with that little math thing there. We're then going to print out what the raw value is and what the temperature value is so we can actually see that. And then we're going to use this get data function and send the temperature value to the server. So we have a function down here called get data. And again, this is a lot of copy and paste. You just plug in what you need to plug in. So you're going to connect to the server that we already configured. So crappy-ai.com, that's a server value. We're going to connect at port 80. We're going to use the get method at /temp ?temp equals. So that's the value that's going to come in, and then this is the value. So basically, this is where the server is, and then this is the path to the variable value, and then this is the variable value. The rest of this is all basically copy and paste. So that is what's going to send the value up to our server. Let's see here. And then from here, string web value get from server. So this is going to be the command that comes back down from the server. So get from server. So basically, we're going to connect the server at port 80, get command. So it's going to get the value that's from there, and basically it's going to send that back. So this is all kind of copy and paste, and you're going to return the result. So the result is going to come up to here. So right, web value is what's going to come back. And so what we're going to say here is if web value equals on, digital write fan pin high. So high means on. That's going to turn the fan on. And we're going to print out fan turned on. Else, so if it's something else, fan pin low, fan turned off. And then we're going to delay for here for 5 seconds. And then it's going to go, it's going to loop through again. So basically that's how we're able to send the temperature value up to the server. And then that's how we're able to grab the command from the server and actually trigger something on the Arduino. And again, all this is just kind of stuff that you got to play with. The big thing to understand whenever you're dealing with Arduino is don't overthink it. Again, like because it does this web stuff, you can actually run a full-fledged web server on Arduino. Well, you can run a web server on Arduino. And the problem you run into is because you can do that, people try to really overthink what you can do on Arduino. The big thing to realize with this is it really is copy-paste. It's like you copy and paste whatever you want to have happen, and then you simply modify like the little bits in order for it to function. But that's basically the Arduino, and that comes, oh lordy, I do believe, yep, that is the end of the project, and therefore the end of the class. Any questions? Yep, back there. What's that?
I don't understand why we're pulling the value of the temperature with Arduino code from the server.
No, we're not. We're pushing the value of the temperature up. We're pulling the command value down. So on or off. So when I tell it to turn when I say I'm hot, that's what. So 11 Labs triggers the function on my server to set the command to on. The Arduino then reads the on command, which then turns on my fan. Yep.
It's only for the command that needs to execute.
Yep. Any other questions? Dun, dun, dun.
So when we talk, coming back to what you initially said about what part AI is playing in this whole stack, really it's just converting the language to a query that you can manipulate in code, right?
Yep. Yeah. Yeah, and that's where it's like with, 11 Labs is very interesting. Like, so again, I had my own business. I had 9 employees, the whole 9 yards before the Great Recession happened. I do have to say, like in this whole AI world, like I hear about all these trillions and billions of dollars people are spending. I have to say, 11 Labs is the first thing I've seen in 3 years that I know I can make a crap ton of money off of. Like this is the first AI product that I've seen that in like if I had employees, I could ship the hell out of this. Because you could go to basically any business. Because like, so I used to be was very qualified back in the day, so I have 100 hours in like Avaya systems training. So I used to sell Avaya like auto attendants, like putting receptionists out of work is what I did for a while there. And again, like the idea with this system is any small business, like again, I'm from Asheville. Every microbrewery, imagine them simply having an AI telephone assistant. So when somebody calls in and says, "Can I bring my dog?" the phone is immediately answered and the answer is given. Because like in Asheville right now, our economy is going sideways. We have like all these breweries, but none of them are actually successful. So you walk into this huge, like you walk into like a 10,000 square foot or 20,000 square foot brewery and they've got 1 employee on staff. And so they're not answering the phone. So you're like, hey, you've set up this system. It costs you, after my fee, it costs you 25 cents per call. And that they can know like what beers do you have on tap. Like you can literally say, hey, what stouts do you currently have? And it'll say, oh, these are the stouts that we currently have. Oh, do you have any food today? Yes, this food truck is going to be here today. Crap, how much is the pizza? Here, pizza's going to be $20, right? So it can do all that kind of stuff, yeah. Any other questions? Cool.
But it could also set you back like $100 because the old man just flirted with the
Well, yeah, well, that is where, so, yeah. So in 11 Labs, again, 11 Labs is a pretty complicated thing. And so one of the things is you can max out the time of the call. So you can max it out at like 2 minutes. And then again, with that the system prompt that you give it, like, so they have an agent that will create a system prompt for you. And that prompt can be like this long. So you can figure out what you don't want to have happen. Yeah. Oh.
Thank you.
Yeah.
So much. This was a fun one.
So yeah, take the paper, leave me the 3-ring binders, and yay, we survived.
Failures were fun.
Yeah.
Great.
Yeah. I mean, I was expecting the disaster, but I wasn't really quite expecting that bad. It's like, wow, this is worse than I was expecting, honestly.
Every time I've done a live demo, it's never going well. Live demo, sometimes it's happening. So you say like a connection fail.
Yeah.
It's not something that you can control.
Yeah. Oh, hello. Hey.